Hi, this is AD Burrows here for CG Masters. Today, let's take a look at some enemy AI in the Blender game engine. First though, let's have a very fast recap from last week. We went from just having a block out to appending in the camera and cube from our CG Masters resources, which in this case could all be found in Chris's FPS tutorial. Then we tweaked a few settings to just customize for our purposes. And we took a look at setting up the point system. I also, of course, released the blockout file for you to play and, if possible, offer any feedback, for which I'd like to say thank you very much. It was all extremely useful. I can't tell you how helpful that is, actually, to not work in a vacuum. And I'm actually really excited and not just a little relieved to hear that the idea of at its core seems to have some merit to someone other than myself, basically. I've taken on board the comments, and also I've learned a few things about how to possibly take the presenting of this further, so thank you again. So this is going to be a bit of an exhausting and perhaps complicated and confusing exploration, for which I apologize. So if you get lost, don't worry, this is perfectly expected. And frankly, I wouldn't blame you if you shut me off pretty fast. But if you really want an example of enemy AI, and I think a fairly decent one in the Blender game engine here, then you may want to watch this multiple times. And really, I think it's best to take a look at the game, take a look through the scripts and the setup, and then you'll definitely start to put the pieces together and probably even improve upon it, in fact. Don't be too disheartened if you think that it seems kind of confusing, and of course shoot me some comments if you need some further clarification. I've also updated the GDD with a compilation of the comments, and very briefly these were that generally the response was overwhelmingly positive, and that parts of it are disorienting because it's at such an early blockout stage and much of the map looks the same, so it makes finding the last bags difficult. And another point was that potentially there could be more goals and timed objectives and things like that, and that's something definitely that I should include. And then there was a whole bunch of other comments and so on and so on, so thank you very, very much for that. And I'll always be interested in getting some feedback along the way, so please, the door isn't closed on that or anything. Please give me a comment if you have any thoughts at all, really. So thank you very much. So now let's take a look at how to prototype out this sort of enemy. And while we're in the GDD, let's take a look at what we're working towards. Sorry, I mean the game's design document for anyone who tires of acronyms pretty quickly. So the main enemy is this swarm, and we've got a few images there for artistic reference. So let's take a look at the look, and it says the enemy will be represented using a particle system. And in order to recognize the swarm in adjacent streets, so instead of it, if you think about Pac-Man, you've got that top-down kind of thing, so it's easy to see where all the ghosts are and things like that. So if we're in a 3D situation, it's probably going to be helpful to kind of get forewarning that you're not just going to walk straight into it. And so in order to be able to sort of see and hear it coming, the swarm will affect nearby lighting, either dimming it or turning it red. And when the player is spotted, a post-processed effect or overlay will help indicate to the player the ray's in danger, or in other words, just, you know, get the hell out of there, basically. So particles in Blender aren't really officially supported as yet, and personally for prototyping here, I think I'd actually just like to keep it very, very simple right now. But for some further study on the subject, what we can do is go over to this thread here on the Blender Artists and visit the thread for the Easy Emit add-on. So if this is something that you want to get into, then maybe check this out. And in another tab, I have the YouTube channel of the person who's working on this, and an example of that particle effect in action and its settings that you can see on the right hand side there. So that might be pretty cool to investigate if that's something that you can't wait for, or that's something that you want to desperately be able to achieve in Blender. Maybe this is the place to go for that. And there's a fair few pages on this thread, so it might help you kind of get things working if it's not particularly working straight out of the box. Personally though, as I say, I'll be taking the manual emitter type setup, which I'll show you in just a moment. First though, I just want to select the enemy. So let's just go and find it here, and we'll just sort of analyze this for a moment, exactly what the setup is. Now I believe the enemy should be just under the bridge here, so let's just select it. and then I'm going to hit Shift Space just to take a look in the outliner here, and you can see that we've got the enemy cube, and there's a few things parented underneath. So we've got the cone, which is basically acting as the eye of the enemy, and it's sending messages back and between the enemy. Then you've got the particle emitter, which is just this plane here, which is going to emit particles. And it doesn't really matter what's happening with these really visually too much, just because they're not actually rendered. We can see them in the 3D view there, but we're not actually going to render them. So if I just hit Alt-Z to take a look at textured mode and press P, you can see all that goes away, and all we're left with is the object that's being emitted from this particle plane. Also, we have the sun, which is, sorry, not a sun, this is just a point lamp, which I've not renamed yet. And basically this is just a light which is going to allow the player to be able to see it as this light spills around into neighboring corridors and so on, so it kind of gives you an indication that it's kind of close by. So basically in Pac-Man you have a top-down view, so you can kind of see where the ghosts are coming from, and that's kind of interesting. It's kind of heightens the tension of it because you can kind of see it coming, sort of like the same thing as the Jaws music, as in you kind of get that feeling that the anticipation is really what it's all about. So that's kind of what I wanted to add in, the extra anticipation by having this large spill light. I did actually go through a different method where I had lamps in the scene where this was being calculated the distance from that lamp, and then it was setting those lamp colors. It was adding red to it and dimming it down basically, but it seemed to be quite processor heavy the way that I did that. So I should put a caveat on the whole thing really, that this is just essentially the way that I've gone about it. This isn't necessarily the best way to go about kind of achieving the behavior and general AI of what we want to do here, but this basically, well, it certainly worked for me anyway. So the particle plane, this has its own set of logic bricks to it as well. So let's take a look at that. So we have an always sensor, which isn't triggering every single frame. It's taking a breather every few, and before it kind of again triggers this actuator. And it's an edit object actuator, and it's going to add in an object, and in particular it's this plane particle. So the particle plane itself is actually on another layer, which I think is the second layer. And let's take a look at I've got visible layers selected in the outliner here, so we can easily find it. And then I'm just going to press the period or full stop on the numpad just to zoom into that view, just to view the selected. And you can see there is our object. And this is an important point to make about this particle plane, is that the emitted objects do need to be on another layer, which is why this is sat on layer 2 and the rest of everything else is sat on 1. So the next thing we need to look at is the logic of how this is working. Now the way I'm going to break this down is first to take a look at how this is roaming around the level. So let's just take a look at that first. However, in the game design document, let's just take another review of how the behavior is written down here. So we have the enemy roams between a series of waypoints at a speed about the same as the players. And when the player is seen, the enemy can pursue faster than the player can run. And if the player manages to avoid line of sight with the enemy, then it will go back to it'll go to the last place that the player was seen, and then do a sweep to look for the player again. And if the player is still unseen, then the enemy will just continue to roam its waypoints. If the player is touched by the enemy, then the player is killed. So let's take a look at how this gets around the level. Basically, there's this cube and there's these waypoints, which one is hidden just under there. And the waypoints are basically just empties as well, as you can see, denoted by the symbol there. And we've got these 5, and let me show you where they are in the level. And this is how the enemy is getting around. It's basically choosing one of these 5 at random, and then it's kind of plotting a path from its current position to wherever that is. And if it sees the player along the way, then it's going to change tact and start to pursue the player instead. So let's take a look at the actual logic bricks on each of these waypoints. Let me just get one because it looks a little confusing like that. Let's just get that one. So all it is it's got 2 states on it, and it's a collision sensor with it's looking for only something with the enemy property, because obviously we don't want to be triggered by the player when we're doing this. And then it's going to tell the enemy that it's reached the waypoint, and then it's going to set its state to the second state. So let's take a look at that. And then here we're going to delay. We have a delay sensor, and we're going to wait about 10 seconds, and then we're going to set the state back to 1. And the reason for that is when the enemy reaches the waypoint, I kind of don't want it to go crazy and then start trying to look again for another waypoint and potentially choosing the same waypoint that it's at again, and then it kind of might look a bit strange on screen if it's doing that. That's based on some early tests that I did. So that's kind of basically, I'm trying to just have everything just chill out for a minute when it reaches the waypoint, just to take a little bit of a look around. And basically, let's take a look at the way that it's sending the message reached. So what does that mean to the enemy when it's reached? It receives the message reached, and at that point, what it does is it sets itself to the second state and resets the timer. So I should probably show you the fact that we have these two game properties, the enemy and the timer, and the timer is what is being listened to here. So when that hits 2 seconds, that's when it's going to choose a waypoint to go to, and then when it chooses, it's going to do its thing, and then when it reaches the point, when it reaches the waypoint, it's going to set itself to the second state and reset the timer to 0, and it's referring to that timer. So let's take a look at the second state. At that point, we're going to take another delay, and then we're just going to return back to the first state, and then again reset the timer. So that kind of might seem a little bit pointless, like we're making everything wait. Basically, when you do that, it allows you to kind of come back to the first state, and you'll notice that we're listening for this timer to hit the 2 seconds again, just to try and reset everything back, really. As I say, that's not necessarily that clean a way about going about it, but it just seems to work for me anyway. Or at least it works well enough for this prototype. Let's analyze the patrol script a little bit, as now that we've seen those 5 waypoints. Oh, by the way, we have of course got this how the game works text file in here, so if you want to kind of read through some of the ways in which this is set up, this is kind of being covered here, but maybe not in as much detail as I'm trying to cover it here right now. But anyway, let's go over to the patrol script, then go control up arrow. So let's go up and then take a look at this. So I'm not going to go really too in-depth into Python and how to script in the game engine as such. And as you can see, these are pretty simple scripts anyway, so hopefully that's not going to be too necessary. But rest assured, Chris at CG Masters has got some great introductory videos into Python and some other intermediate steps in the Python as well. We also have in the templates down here, we've got the game logic template examples as well, so you can kind of analyze them, and I'm sure you can find other resources as well. But as I say, Chris at CG Masters has got some definitely really good starting points there to get into this kind of thing. So first of all, I need to import in the Blender game engine modules, which is what we're doing there, and then I'm also going to import the random module as well, which means I'm going to want to do some random choices. So we'll get to that in a second. Then what we're going to do is we're going to define a patrol function, which is just, we can call out anything we want really, but I'm just going to call out patrol and then set the conditions of this function here. So it's going to carry some variables inside, and it's basically the very standard ones, as you'll see from many of the other tutorials about this. This is the scene, main scene, this is the controller, this is the actuator. Now the actuator in this case is actually labeled as such, and that's going to be called steering. So if we take a look at that, you can see this patrol script is attached to the actuator that is called steering, and you can see here it's going to wait for 2 seconds before it triggers this script, and the timer property here is what it's waiting for there. When that reaches 2 seconds, it's going to trigger this and going to look for a random waypoint to choose, and then it's going to input that random waypoint is then going to be the target object here, and it's using the steering actuator set to following, and we've got some other settings there. We can kind of set the velocity and acceleration and turn speed to help with how difficult this enemy is basically, and how fast it is for that matter. So let's go back to the patrol script now that we know that this target object is what's being filled in a second. So let's take a look again. So the waypoints is going to be this tuple, basically this kind of list of objects, scene objects. So you got scene, which is that scene there, so really it's actually all this information. Then we're just going to the objects in the scene, and in particular we want the waypoint 1, waypoint 2, 3, 4 and 5, and they're all separated by a comma, creating this essentially this array of objects, this tuple. And I've just got a little comment at the end there, which is just setting that to waypoints. Incidentally, if we just put on the color coding to some of the things that we can see, that might make things a little bit easier. But in this actual theme, it's not actually that easy to see what we're looking at. So I'm actually going to go back to the default theme, which for me, I feel like without customizing things too much, I think it's probably one of the better ones to actually look at scripts in. So I'm just going to go to themes and then reset to default. And then let's take a look at this again. Let's take a look at this. So here we are, we've imported these two things in. We have this waypoints that, as we talked about, which has got these 5 different waypoints in, and then the new waypoint is a new variable that we're going to assign to be a random object from, or a random choice from those objects found in the waypoints tuple. And I've got that commented out as being just choose a waypoint. That's just what's happening there. Then I'm going to print out the waypoint because that's kind of useful for debugging. So if we go to the window, we can toggle the system console there just to bring that up. And I must have that in the background somewhere. Where is it? Here we go, we're getting some feedback about what we're doing here, and you can see that it's been choosing these various waypoints and letting us know which one it is. So I'm just going to put that down there for a moment. And then it's actually going to do something useful at that point, or very useful, which is to assign the actuator, which is it knows that that means the actuator because of the variable we placed earlier, and then it's going to the target. So this what you can put after the full stop there to dig down into the actuator depends on the kind of actuator it is, but in this case it's a target, and we're going to set that to the new waypoint. And we know that we can get to the target because in here we can see that that says target on there. And not only that, we can actually see in grayed out in the tooltip, and it says steering actuator dot target. So that's a pretty good guess as to what to probably place in there. And let's see. Let's take a look at the next thing, and then all we have to do is just simply activate the actuator. So once it reaches the target, it's going to send this message which is reached, and then it's going to set itself to the second state and also set itself reset the timer to 0. But what else is it doing? Well, in this first state, the only thing it's really trying to do is just look for the player, and that message is what's being happening from the eye. What happens here is that we look for the player, we've seen the player, and then at that point we're going to shift to another state, the third state along, and then we're going to start getting into that. So let's take a look there. Now, as soon as we get into here, the first thing that we're going to do is to do these two things, and that's simply to, we know that we've found the player now, so we don't need any scripts to drive this. We want the player, and then we've sped things up now, so we're really going fast towards the player, much faster than the player can go. And also we're setting this filter. Now these things are pretty cool because there's quite a few of them to choose from, as you can see there. I've chosen this Sobel one, which is the filter here. You probably be able to tell. In fact, let's just go full screen and bring the player right in front of the enemy. So let's go and grab this, and then press G and then Shift Z and just bring that about there. Let's take a look through the camera. We'll rotate so we can sort of see what's happening. So there's the enemy. Let's see if it has any joy trying to find us right now. So let's press P. Yeah, it's found us straight away. And you can see this kind of this outlining that you're getting. That means obviously we've been seen. And so we're now on state 3, just to recap there. And then we're going to find the player cube, and we're also going to do this filter thing. What's happening there is it's basically just going to keep on pursuing the player. And if we collide with the player, that is actually on the player itself. So I'm just going to need to reselect the player again, which is here. And then what you can see on here is if we collide with something that has the enemy property on it, which we have on the enemy, we're going to do these things: restart the scene and also set the points back to 0. So let's take a look at the enemy again and take a look at its next states. So we also on this third state have this other message that's being listened to, and that it might receive the lost message. So while it's searching for the player, it might receive this lost message, and that's going to come from the eye that we'll take another look at in a second. And but let's just assume we're aware of the eye for now, and then that's going to do these. Actually, it's connected to 3 things, but this is kind of a mistake on my part. It only needs the 2. This is me trying out some different filters basically, but I can actually delete that. It's not really a big deal. And then we have this other filter, which is just remove the filter. So in other words, when we've lost the player again, we want to step down the alert and the visualization that the enemy has seen the player and kind of let the player know that they've escaped temporarily at least. And then it's also going to go not back to the start again to sort of start the cycle all over again. It's actually going to go to the fourth state. So let's take a look at the fourth state. Now, the fourth state, it's still looking for the player. And if it sees the player, then it's going to just go back to the third state again. So that's fine. In fact, I think we have that in all states. So in the first state, we have in the player seen. If that's seen, then we're going to go to state 3. In the second state, if the player is seen, go to state 3. And then that is state 3. And then again in state 4. Then we also have these this always sensor, which is now controlling the steering, and it's actually looking for the sphere instead of the player now. So once it's kind of lost the player, it substitutes a sphere as being kind of like representing its memory. So the sphere is at the place that the player was last seen. So it'll go to that last place and then stop for a moment and take a look around, and if it doesn't see the player after a certain amount of time, then it kind of returns the player back to, oh right, you know, you're okay again, you've not been seen. So that's what's happening there. It's actually steering and finding the sphere at that point, but if it receives a message called back, it's actually just going to go back to the first state again, which is kind of like saying, well, I've not been able to find the player again after a set amount of time, so just forget it, just go back to roaming around the level, which is found on the first state, and also we're going to reset the timer to 0 as well. So that pretty much covers the states of the enemy, but that's not entirely complete without understanding what's happening with the cone. And if we take a look at this cone here and play the animation, you can see that that's what's happening there. We have this rotation value, and it's basically looking straight out of the very, very top of this cone, and that's representing the eye. So we could actually, it's only looking forwards. So if we wanted to, we could actually make it even harder. If we gave this a wider rotation value that it was looking, it would actually be even harder. So that's a few ways in which I could actually increase the difficulty of this enemy. So let's take a look at how we're going to be able to do that. That is on the graph editor. Let's take a look at the graph editor, the dope sheet. Let's take a look at the dope sheet and then take a look at the action editor. We can see we've got the cone action there. So that's what we're probably looking for. Let's go back to the 3D view actually. Let's go back to the logic editor. So let's take a look at this is the first state of the eye. So basically what's happening is straight away, it's always going to do this. This is kind of the important one, is it's going to play that animation. So this is an action actuator, and it's just going to continue to play from frame 1 to 30, and it's just going to keep on doing that. And what else is happening while it's doing that is it's sending out a ray sensor. So we've got this ray sensor, and it's looking for the player, and when that happens, when the ray that shoots out of that cone hits the player, it's going to trigger this module's Python script, and then that has a couple of actuators set to it, and it's going to set to the second state, and also it's going to send the message that the player has been seen. So let's take a look at the second state first. And now while this happens, you've also still got the cone action happening, and you can see that's pinned there. So we can view this on whatever state that we move to. You can still see it there, although there isn't any controllers in the middle there. So if we're in the second again, we have this ray, which is still happening. And then this is now doing the ray last script, and that's going to set the property of last seen to 0. And last seen is a kind of timer. Basically, let's take a look at this. We're going to go from here. When it hits and it sees the player, it's going to say, right, I've just seen you. And it's going to count down to 0. It's going to be like, right, okay, I've only just seen you, so that's 0. If that gets up to 1 second, it means it's not actually seen you for a second. It's not seen you for 2 seconds. If it's not seen you for 3 seconds, I'm kind of telling it using this property sensor, using an interval type of the last seen timer type. If it hits about 3, then basically I think that you've lost the player, and the player has done well enough to avoid you. So at that point, we're going to send a message to the enemy that things are lost, and also set the state back to the first state. which we're going to be able to see there. So when that, let's take just glance back again, we get in that lost message, which is what we kind of reviewed here. So when you're in the pursuant stage, in the third state, where we're closing in on the enemy fast, on the player fast, I should say, if you receive that message lost, this is where it's going to pull it out from doing that, and it's basically going to remove the filter and also go to this cooling off period where it's kind of going to go to that last point that it saw. Let's go back to that and just analyze the I there, because that's not going to make perfect sense until we see how this is all sort of related together. And the ray.main and ray last.main, these are the ones that we need to take a look at now, just to complete the AI on this really. So we're nearly done. And I realize that this is a lot and we're going through quite fast, and it might seem kind of a little bit on the confusing side, but much of this I think kind of probably would take a little bit of time to kind of analyze what's going on, because it took me long enough to set this up, believe me, just trying different tests and so on to make sure that any bugs were kind of ironed out really. So we start off with this Ray script. So first of all, I'd just like to thank Goran Milovanovic for the inspiration on this particular script. This is just, I've totally learned this from him. And on his site, he's got his nilunder.com website, where he offers some extra services to do with the Blender game engine in terms of prototyping out some Blender games, which is a fantastic idea. And he has a lot of very detailed YouTube tutorials, which are a very, very great resource as well. So many thanks to Goran. And basically, this will draw a line if the enemy sees you, and also it'll activate the player scene actuator and change the state to pursue the player. So this has got a main function, and again we have the some typical things that you would get when you importing in the scripts and the modules that you need. And in particular, we're listening for the sensor that is the ray sensor, and then if the ray is positive, in that if it does see the player, because we have the player game attribute there that we're listening for, so not just when you hit any old thing, just when you hit the player, it's going to be a positive at that point. And so we would want to see what's happening, so we want to render it. And this is the way that you would set that up. And the main thing is we want the hit position, because we're going to use that shortly, and this is the color that is being used for how to draw it. And then at that point, it's seeing the player, the game is up, we're coming for you. So we're going to have the player scene and we're going to change the state. So the next script to take a look at is the ray last script. And this, I believe, is actually the last script to look at as well. And again, you can see all these scripts are actually quite short and not particularly too in depth, but they definitely do a great job in trying to bring this prototype to life anyway. But we have this, again, a very similar start. And if the ray is positive, then it's going to, again, draw the ray. It's going to activate the reset actuator. So, what's the reset actuator? Well, let's take a look. It's this is what's called reset. So it's going to say the last scene is going to be set to 0 there. And then let's take a look at the last piece of the puzzle, which is that the scene.objects sphere. So we know that we have the scene here, so we have the total scene, and then in the scene we have some objects, and then we can name that object here. This is the sphere, and then that sphere's local position is then going to be set to whatever the hit position was. And so let's take a look at that, what's happening there. So if I just zoom out a little bit, you can actually see in a safe area of the map, which can't be seen, there is this sphere here. And I've just rendered the collision as a cube there, just because it doesn't need to be as complicated as a sphere or anything. So this sphere doesn't really have very much on it, but if it does receive the collision, if it does collide with the enemy, it's going to send a message back to the enemy just saying back. And so what happens there is with the enemy, so if I just select the enemy again, down here, select the enemy. So here's the message. So this is what we were getting from the sphere. And when it hits that sphere, it's basically going to just go, hey, you've hit the sphere. Let's just go back, which means we haven't seen the player in a while because we're moving the sphere at the location of the player. If it touched the player and the sphere at the same time, it would just end the game anyway, because the player has a wider collision. So that's not a big problem. So that's how that is all set up. I realize that's very confusing. One other thing to just note is that you've got this eye here and several other things that you can do with these game property values. We have these eyes for information, and what that means is when you play the game, so let's press P to play. We're not really getting very much happening right now, but if we were to go to the render tab and turn on debug properties, we can also find that in other places as well. The game here, we've got show debug properties and some other options that are down here as well if you don't want to mess around there, and then press P to play. Take a look in the top left. You've got the two enemy cube values and two cone values. So that's the enemy cube itself and the enemy's eye. It's immediately hitting state 3, the pursuant stage. So I'm just going to move the player cube out of the way. Go into our wireframe. You can see that I'm using the new pie menus. Let's try grabbing this here. And let's move that back to some safe space over here, for example, underneath the underpass. And let's go to the textured view again with Alt Z and then press P. And then take a look in the top left, we have a timer going up. It's hit 2 seconds, and then immediately after 2 seconds, it's decided to trigger that waypoint script to take a look to where to go. Again, let's play. And you can see the cone is counting up last seen because it hasn't seen the enemy, it hasn't seen the player at all. So that value should hopefully get quite high. And then the cone state is 1. So it's not really a big deal there. So let's see what happens here. The enemy state, it's now on state 2. Now it's gone back to state 1 again. So it reached the waypoint. And in fact, let me just do something else. I'm going to bring up the console here, and I'm just going to trigger this again. You might be able to see that this isn't necessarily perfect logic, but off it goes to search for its state, and it chose waypoint 4 and waypoint 2. So it did like an immediate double check of the waypoint, which is an error on my part, but it's kind of an error I don't really need to worry about. It's now looking for waypoint 2. And then it's off to do its business, and now it's found that place, and now it's off to waypoint 4, and so on and so on. So let's just escape out of the game. So that concludes the breakdown of the enemy and its AI and how all that works. There's way more we could do with the AI to make it more intelligent, but I think this simple example is quite a good one for getting an enemy to do what at least I needed in this case. Of course, you could change the logic slightly to mean that the enemies were not only pursuing you, but also firing a weapon at you with some degree of randomness every such and such an interval. That would be to make it a bit more like a traditional shooter game, I would guess, in that case. But anyway, there you have it. Congratulations to you if you made it all the way to the end. Kudos to you. I think you must be in the minority, and you must have a very bright future ahead of you with that level of tenacity and staying power. And seriously, I really do mean that. So thanks again for joining along with me on this journey, and stay tuned for some more art related entries coming very soon. So bye for now.